In this video, we'll be going over quotient rule in calculus. So, when do you use quotient rule? So, you use quotient rule when you're doing the derivative of a function divided by a function, right? So, in terms of writing this, how does this look? So, when we write this out, this will look like the bottom function times the top function, but the derivative, we'll put this in brackets just so there's no confusion, minus the derivative of the bottom function times non-derivative of the numerator, all over the bottom function squared. Now let's take a look at an example using quotient rule. Okay, so I've written the quotient rule right above, as you can see. And here's our example. So let's use the quotient rule to find the derivative of h of x. So first, we're going to put the denominator on top. Let's make sure we put brackets. So this is x cubed minus 1. And we'll add parentheses because we're going to multiply the numerator, but the derivative. So the derivative of 3x squared, right, we're going to bring that down, which is 6. Right, so we have x squared 2 minus 1, which is just x squared. I mean 6x. I apologize. So this is just 6x in bracket minus. Now we're going to do the derivative of the denominator, right? So we have a constant as we see here. So this will just be 0. But here we have a power rule. We'll use power rule for x cubed, right? We bring it down to the coefficient, which is just 3, and subtract 1 to 3, which is just 2. So 2 squared, right? And then now we're going to leave the numerator alone. And there we go. We have that all over the denominator squared. Now, you could distribute all of this out, and then you could get a more simplified answer. But for the sake of this video, we're just going to say this is our derivative of h of x. So for here, we see no power symbols, right? So this should be a lot more simpler than the previous example. So we're going to bring the denominator to the top to find the derivative of f of x. So we just have 5x plus 2 times the derivative of the numerator. So we see a coefficient, or a constant, I apologize, it's just going to be 0. And we see a coefficient times x, which is just going to be 2. Minus the derivative of the denominator, which is going to be 5, right? Because we see a constant, which is just going to be 0. And we see a coefficient times x, which is just going to be the coefficient itself, which is just 5. Times the numerator as it is. All over the denominator squared. Oops, sorry. Plus 2 squared. Not that we have f of x prime. Now let's distribute this example. So we distribute the 2. So we have f prime of x is equal to 10x plus 4, put that in parentheses, minus 10x minus 15. Also distribute this. Plus 2. Okay, so I forgot to add the x. There we go. Okay, so oftentimes a mistake that I do notice with peers is that they forget to distribute the negative. This negative right here. Right, whenever you see a negative, parentheses, and then some number, right, a number in here, you have to distribute that negative. It's the same as if you have this. This is just -1. Even if you have negative, or if you have infinity, this is just negative infinity. You always, always, always distribute the negative when you have parentheses. Because what this actually means is that you just have multiplication between them. So in this case, we're going to distribute this. So we have 10x plus 4. Distribute the negative into the 10x, which is negative 10x. Distribute the negative into negative 15, and negative 15 times negative 1 is just going to be plus 15, right? And we can distribute this too, which is going to be 25x plus 10x, or 20x. Oops, this would be 25x plus 4, right? And then we can further simplify, because, oops, that looks like a y, that's an x. Because negative 10x plus 10x just cancels out each other. And then we have 4 plus 15, which is going to be 19 all over 25x. Oh, another mistake, I apologize, is 10x. It's 25x squared plus 20x plus 4. Oops. Let's make sure, yep. F prime of x is equal to this. When you fully distribute everything and simplify everything, that is your final answer. Okay, now let's take a look at this example. If you will, pause the video to try it on your own. This one will require you to use both quotient rule and product rule. If you don't know product rule, I recommend that you watch my previous video where I go over how to do product rule and when to use product rule. Okay, so let's start off. So we bring the denominator to the top, right, and we don't do anything to it. Right, so we're finding g prime of x. Right, so we're going to bring this to the top. Oops. Times the derivative of x sine of x. So what's the derivative of x sine of x? So as you can tell, there's two functions that are multiplying each other. We have x times sine of x that are multiplying. So if you remember product rule, it states that when you have the derivative of two functions, it can also be rewritten as the derivative of x times the non-derivative plus the non-derivative times the derivative, right? This is product rule. So let's apply that to this example right here. So we're going to do the derivative of x, which is just 1. So we don't have to write anything down, because anything times 1 will just always be itself. So 1 times sine of x, which is going to be sine of x, plus the non-derivative of the previous term we did find the derivative of. And then we're going to do the derivative of the term we didn't do the derivative of, which the derivative of sine of x is just going to be cosine of x. Right? So this right here is the derivative of that right here. Okay, so we're going to multiply this part, right, the denominator here, by the derivative of the numerator. So times sine of x plus cosine of x. Looks like I'm going to run out of space, so I'll just write it below here. So then we're going to do the derivative of this, which we see a constant, which is going to be 0, and we see a 1 right here, which is just going to be 1, right? So we don't have to write it at all. We can just subtract this, which is just going to be x sine of x. We're just continuing right here on this part, but because I have the room, I'm going to write a bit below. All over the denominator squared. And that is our derivative of g of x. If you like the video, please make sure to subscribe and like. And if you have any questions or concerns about quotient rule or product rule or anything related to calculus, please make sure to comment down below. And as always, thank you.